let's come back. We'll look at the other half of these, okay, in terms of what we got for solutions on these guys, okay, for this next problem, number 7. I believe we're trying to find the area of the shaded region. And so we got two circles. So it's going to be basically area of the large circle minus the area of the small. Okay, and of course area is equal to pi r squared. Looks like the large circle, what it's trying to show us is that this distance between the large circle and the small circle is 5 meters. So which means the smaller circle has a radius of 50 and a larger circle has a radius of 55. So I guess it's the large circle would be pi times 55 squared, okay? Pi times 55 squared minus pi times 50 squared, okay? So I don't know, it shouldn't be that bad. It can just figure out what 55 squared is. So I'm just going to show you right here, pull up my calculator and see what that is. It's 55 to the second power, which is equal to 3025. So it's 3025 pi minus, you should know, well, what's 50 squared? Well, 5 squared is 25, so 50 squared is 2,500. Okay, 2,500 pi, and the difference there should be 525 pi, and that's exactly how I'm going to leave it, 525 pi. Okay, the area and the perimeter of this E-shaped figure. Okay, so let's do the perimeter. Perimeter again is all the sum of all the sides, going all the way around. Follow it around, make it all the right angle turns, and add up all the lengths that you travel. Well, we could do it a little easier too. We certainly know there's a length of 70 right here. But do you really know that? So we're going to find the perimeter. You know that there's actually two lengths of 70 because, all right, this piece is 14, but then it says that this piece, this piece, this piece, this piece, and this piece are all equal. And there's 5, 1, 2, 3, 4, 5 of them times 70 times 14 is 70. But then that shouldn't be any surprise either, because if you scoot this piece over here, it takes up there. This piece takes you down to there. This piece takes you down to there. This piece down to there. This piece the whole length. So we actually have two lengths of 70. So that's times 2. Plus, okay, what's this length? Well, that's 50 and 12, so that's 62. But then you have that down here again, so you have two 62s. What else? You double of a lot of things here. This length is 50, and so is this one, so there's two 50s. And let's see here. There's a 25 and there's a 25, so you have two 25s. So when you figure that all out, I think you'll find that the perimeter is 314, okay? So there's your perimeter. Let's go in the area. What's the area? Well, break it up into rectangles, okay? So here, this division here is going to make, what, 1, 2, 3, 4 rectangles. What are the dimensions of those rectangles? Well, you have one which is 12 times 70. Okay, that takes care of this guy. He's done. Then you got the other one, which is 50 by 14. So that takes care of that one. Then you got 25 by, again, what's this? This is 14. Okay. And then another one down here, which is 50 by 14 again. So another 50 by 14. And again, I'm more impressed seeing this than just you writing down the answer, because I know the process that you went through to find that. So You might want to check, but I think when my calculation shows that's 2590, 2,590 square, in this case, centimeters. This number 9 is an interesting problem, okay? It says that the area of the larger square is 100 square inches. All right. If that's 100 square inches, and the area for a square is what? Side squared. The side squared is equal to 100. That must mean the side is equal to 10. So each side here is 10. And I think pretty safely we can assume that F is the midpoint of BC, G is the midpoint, so all the way around. So that means these lengths are 5. So basically, to find the area here in black, we've got to take the large area, which is 100, and we're going to subtract from there. So the area is going to be the large area of 100 minus each of these triangles. Well, what's the measurement of each of these triangles? Well, it's 5 and 5, and the area of our triangle is equal to 1/2 the side times the side. So that's 1/2 of 25, which is 12.5. Well, guess what? This is 12.5, this is 12.5, this is 12.5, and this is 12.5. So what is it? It's actually 100 minus 4 times 12.5, which is actually 100 minus 50, which will tell you that that shaded area there is 50 square units, okay? Let's do some circles in here. Well, let's see. Think about this, okay? Each circle has diameter of 2 inches. Here's 2 inches. Here's 2 inches. That's 4, 6, 8 inches. We've got 8 inches going across there, right? Okay. Now, what do we got going downward? We've got 2 inches. Another 2, 4. So this is 6. So if we're after that area in there, it makes sense that we can just take the area of the 6 by 8 rectangle. So it's a 6 times 8 rectangle minus what? 1, 2, 3, 4 times 3 minus 12 circles. Okay, so that's 48. Now, what's the area of the circle? Well, what do we say? The diameter is 2, so then the radius is 1. If the radius is 1, and so it's 48 minus 12 times pi r squared, but r is 1, so it's 48 minus 12 times 1 squared, which is 1, so it's 12 pi. And that's exactly how you leave the answer, 48 minus 12 pi. Let's look at a couple more here, okay? Find the area outside the small circle and inside the large circle, okay? So there you have that. There you have that. That's the area in question. So it makes sense that the area is going to equal the large circle area minus the small circle area. Now you have to watch this because here, see, this is in inches, this is in feet, okay? So we have to be consistent. What do we want, inches or feet, okay? I'm going to go to feet. I'm going to 6 inches equals 1/2 a foot. So then the large circle would have an area of 3 feet and 1/2 a foot, so that's 3.5 feet. So I'm going to put that as 3.5 pi. Okay, so I'm going to 3.5 squared minus the small one, which is 0.5 squared times pi. And I'll let you figure that out. You can go to your calculator and figure that out. That shouldn't be that bad. Okay? And what about this last one here? All right? The last one, how do we find this region that's shaded here? It looks kind of interesting. All right? It looks kind of interesting, so give it some thought. And let's see. Okay, so basically, all right, if I look at something here, it takes a little bit of thought, okay, because basically this area in here is one whole circle. Let's see what's given to us. The diameter is 5 inches, okay? So the diameter is 5 inches, all right? So we're going to assume here that these are the centers of the circles, all right? And from here to here is the diameter, right? Okay, so that's 5 inches. That means from here to here is 10 inches, all right? Which means that this square here, this square, which is TRUE, is a 10 by 10 square. Okay, so we're going to start with that. And then what are we going to take out of that? Right here. If I remove that, that's a quarter of a circle. Okay. All right, so basically here I got this as a quarter of a circle coming out. Another quarter of a circle coming out here. Another one here. And another one here. So basically I got 10 by 10 minus 4 of 1/4 circles. Well, 4 of 1/4 circles is a whole circle. So it's 100 minus the circle area, which is going to be what? What's the radius of the circle? 5. So it's 100 minus pi r squared. R is equal to 5, so it's 100 minus 25. 100 minus 25 pi. Okay, there you have it.